We're going to move now to the next panel, which is on on aviation 3.0, largely about electric aviation. That panel is consistent with the theme that I raised in my introductory remarks about all the happenings that have occurred in that sector the last year. To lead that discussion, our moderator will be Tess Hatch from Bessemer Ventures. Tess is an aviation expert and has been in several aviation-related businesses before joining Bessemer. I'm going to let her introduce the panel. Tess, are you with us?
I am. Thanks, Howard. Thanks for having us today.
Hello,
everyone. We have a panel of experts that we'll be able to learn from today. I definitely am excited to do so. And we have a jam-packed 40 minutes. So our 40 minutes will start with, I'm going to introduce our three esteemed panelists. Starting with some introductions, I'm going to start with Peter, who is the founder and managing director of Radius Capital, which is focused on advanced aerial mobility and its applications towards positive impact for transportation across the economy. He is an appointee to NASA's Aeronautics Research and Technology Roundtable, the mission of which is to help NASA contribute to U.S. leadership in eVTOL, which stands for Electric Vertical Takeoff and Landing Technology and Urban Air Mobility. He's also the co-author of a national vision and roadmap for advanced aerial mobility. So really excited to hear from you, Peter, today. Second, we have Gur, who co-founded the Amazon Prime Air, did I get that right, Gur? Delivery by Drone project in 2012. And he led the organization for the next 7 years, culminating recently with Amazon Prime Air's FAA certification as a Part 135 commercial airline, which is quite the achievement for drones to be able to carry packages. Since departing Amazon in September of last year, he's gone on to be an advisor to a handful of organizations, one being Dennis Muhlenberg's New Vista SPAC, and another being a subject matter expert in AI, autonomy, robotics, and safety for NASA. And last, Srini, my good friend in the industry, an investment director at Intel Capital. He's responsible for the firm's investment in Joby Aviation, which I'm looking forward to hearing about, in addition to a handful of other awesome companies like OnScale and Verisim. His current investment areas of interest include autonomous systems, next generation computing, urban mobility, and vertical AI. Because I introduced the four of you, maybe we can skip the self-introductions, but if each one of you want to go through a recent, ideally aviation focused, since that's the panel here, investment or advisor role that you'd like to share with the audience and why you're excited by it. Maybe I'll start with you, Peter.
So thank you. I'm really happy to be here and to be part of this conversation. I think when we look at this space, ask some of the questions about, well, what's so interesting about aerial mobility? One of them is it's, I think, a great proving ground for the software stack that is going to allow us to enable robotic systems to be successful out in the real world. And so, building the protocols for data exchange and the systems that enable autonomy, as we do it in aerospace, it is going to be a really strong proving ground, and that same technology stack is going to propagate out into other spaces. One of the places where we've been doing a lot of work lately has been in the data link and the cybersecurity issues to support this type of software stack. We've been doing work on the public sector side as well around defining the requirements for the standards and protocols that are going to enable secure data exchange in a system that is supporting a lot of machine-to-machine interactions and where safety critical operations hang in the balance. So that has been one really interesting area of focus for us. And then the other has been on really sorting through what are the applications that we can expect to fly in the near term versus which are the ones that are further off. And I think that one of the things that people are really coming around to realize about this is that while urban air mobility, urban air taxis as a concept are very appealing from a market standpoint, there are a lot of less obvious early applications that are less demanding on the technology, less demanding on the manufacturing base in terms of scale, but that are very attractive in their own right and are going to give this industry the muscle to scale up, to attract the talent, to build the operating experience and gain the access to capital in order to go and do these bigger things. And so when we look at that, with our investment strategy, we are looking at the core common enabling technologies that support both the early incarnations of flight as well as the later ones. And so we are looking into the supply chain and into the systems that connect vehicles to infrastructure, that define the way that we're going to utilize airspace. When we think about airspace, it is infrastructure, but it's infrastructure that we define in software rather than infrastructure that we define in asphalt and concrete. And so that is another area where we're spending a lot of our time.
Thanks, Peter. Gur?
Sure. Look, I spent the last 8, I guess, air quote years working on package delivery, last mile package delivery. So, when I left Amazon, I decided that I'm not gonna, I've done enough of that and I'm gonna do other things. I think about my areas of interest, and I'm neither an investor nor a startup founder. I'm sort of in between. I have a lot of interesting projects that are either my own or people that I help, either usually in the team, the technology, and the market defect that is trying to be addressed, being of interest to me, and then in the triangle of AI, robotics, and physics. That's always been. I'm more an engineer than I am sort of a manager usually. Probably the area that I'm most interested in right now, and there's a company I'm helping out in Boston called Ascent Aerosystems, is in trying to look outside the sort of regular multi-copter configuration and trying to build something that's more robust. I think quadcopters, hexcopters, octocopters, etc., have really unblocked the industry in terms of our ability to test out new applications and new scenarios really quickly, but they have really severe limitations around resiliency to weather and flight times and sort of just the ability to interact with the environment safely. I mean, they're very fragile. That's just the reality. Anyone who ever flew a multicopter knows that if the environment touches them, then everything goes bad, wrong really, really quickly. So I'm always been interested in other alternative configurations. In prime air, the configuration that the team has ended up taking towards certification is very unusual, and for a reason, right? You have a specific mission you're trying to solve, and you build the optimal aircraft to deliver that mission, that concept of operation. And I feel that carrying a payload and carrying a payload in any weather situation, sort of the two key metrics that really make aviation either work economically or fail are dispatch reliability and fleet productivity, right? So can you dispatch when you need to in any weather condition, and can you fly fast enough and far enough to get to where you have to actually perform the mission? And is your fleet on the ground or in the air? So when you look at commercial Part 121 airlines, when these two metrics are at above 90, everybody's happy, and companies are successful. And when they're lower, generally things go bad pretty quickly. So I tend to think about there is a missing point in the small drone, the small UAS market that really needs very, very high rates of dispatch reliability and fleet productivity. So you can think about safety applications. If you have to go do search and rescue or support a fire crew, you can't wait for good weather. You can't wait for low wings. That just doesn't. You have to fly 95, 98% of the time. So that requires a different configuration, a different form factor, and that's an area I'm spending a lot of time thinking about and doing hands-on work, I would say.
Yeah, for drones to ubiquitously and safely fly in our airspace, it needs to be 24/7. Interesting. Srini, and it can totally be Joby.
I think that is So we are a broad enterprise software. We invest in a couple of different areas, including autonomous and 5G. So we aren't specifically investing in aviation. So for us, a lot of it lies on data platforms, compute storage, and how we transmit this data. So really, if I had talk about the last aviation, obviously it was Joby. But we do look at a number of software companies. So for me, as Peter mentioned, the software layer is pretty interesting. And also the tool space, right? So the picks and shovels. And I think, Tess, you probably know there are companies that are feeding the frontier tech industry. And so, you have portfolio companies which are building parts for the frontier tech, but there are also a new generation of, I would say, manufacturing software companies that are coming in to sort of fill the gaps between where the majors are. So if you take manufacturing execution software or product lifecycle management, there are things that were made for large incumbents and they were made for the old world. They're not cloud native. So we're seeing this new generation of software startups that come in that can sort of fill the gaps for the new frontier tech companies. So that's one area of interest. What I want to broadly see there is if there's applications beyond frontier tech alone, like you don't want a startup selling into 10 other startups. That's the multiplication of risk. But also we want to see where else can it broadly apply. And I think the second area I would probably say is the area of safety. I know, we all know that eVTOL operations, they're all going to take time. We are probably going to see some logistics and other applications in between. But the idea of having some autopilot or assist software in that slow mobilized sense, what is the mid levels of automation before it gets to full automation? I think that's a space that we continue to follow. I think so. Those are the two areas of interest for us. We are not necessarily looking at making any more sort of hardware OEM investments at this point, because I think, as you know, the space is very well represented at this point. We have all sorts of configurations, but very much in the software infrastructure layer is where we focus on.
Thanks. Thank you.
And maybe if I can just ask a question, but that concept of intermediate autonomy always worries me. If you look at a lot of the NTSB data from larger Part 25, Part 21 operations, usually if the autopilot is flying a plane and nobody's messing with it, things are very safe. And if the pilot is well trained and current and flying the plane manually, everything is fine. And the in-between, where the aircraft performs some of the automation and the pilot is performing some of the other tasks, these mixed autonomy modes is where there really are safety issues. So I've always had the philosophy that we should jump directly into complete autonomy. And actually not against remote piloting, as long as the latencies and the resiliency of the links are high enough, just because you can train for it. But these mixed autonomy modes really worry me. I think they're easier to certify, but they're not necessarily the kind of safe system we want to deliver in the market.
I agree with going right to level 5 as well, and the dangers of potential 2 or 3 or 4.
No,
well,
I think
I would
just say it's the religion between the same. It's a Tesla versus Waymo. I don't think any of that has been proven out yet. Both sides have sort of some arguments there, and I really have no position on that. 2 years back, I sort of believed with the whole Waymo approach, but if you're not backed by a large company and you don't have a path to commercial operations, you don't have a huge enough war chest, I don't know if you really survive that period of time, 5 or 7 years, where you can get to full autonomy. So that becomes the big issue for a startup.
I would agree with that. I mean, certainly we've seen that in automotive, where this semi-autonomous, these systems actually work against human nature, and they become very dangerous. When a car is, driving placidly down the highway, and the human operator, or the driver, starts to trust it a lot. Then we're pattern matching beings; it's human nature. But then when that automobile encounters a hectic situation that it can't handle, it throws up its hands and asks this human who isn't paying attention to suddenly take over and make a decision for it. That isn't working well. Fortunately, I think in the airspace system, we have a system that is more rules-based and more consistent, and one that has allowed us over recent decades to clearly define different roles for automation and for people, and people who are playing different parts of the system, from pilots to air traffic controllers and others. And so I think that this is the reason that I'm excited, that I think that we can mature these technologies for autonomy. We can do it in aviation, where the system is very rules-based and very consistent. Think about the contrast between driving and flying. In driving, we have different driving cultures. Even within the United States, people drive in different ways in different parts of the country. It's a very human, emotional, cultural experience to be on the road in Boston versus in Phoenix versus somewhere else. Whereas in the airspace system, it's the same. It's the same across the board, and that makes it more conducive to bringing automation into the mix. And so perhaps we will find ways that allow us to take this incremental approach, but to do it in a way where we can maintain a handle on the level of safety that we're designing in.
Wonderful. So our panel today is Aviation 3.0. And taking a huge step back, we have drones under 400 feet. We can have Cessnas and commercial aircraft between that and 30,000. And then there's the stratosphere with balloons and blimps and high altitude, long endurance platforms. We have different types of technology for aviation. There's a trend towards electrification. There's the potential for supersonic again. The world is our oyster for the Aviation 3.0 at a high level. And then I'll go into more short term. So a high level and long term. What trend, what technology in aviation are each of you most excited about and think will be most, I hate to use the word disruptive, but will really help push this industry forward, will be the next technology catalyst for the industry? And I'm going to say the same three, but I'm going to switch who starts every time. So Gur, you get to go first this time.
Sure, I'm happy to. I get to sort of talk about this almost every day. So I usually have 3 topics that I talk about, I consider, and they're not in the concept of operations or market entrance. So I think if we just sort by, let's say, social interest, I think decarbonization is sort of probably the top interest that's happening right now. I don't really care sort of where you are on the spectrum of thinking about global warming, but nobody can be happy with the kind of pollution that the airline industry, from small to large, is producing, and that of course extends to. So it's not the only polluting industry, but it's definitely a major one. I tend to also say decarbonization and not electrification, because there are many ways to remove carbon from the environment. There's some pretty interesting work happening now around the synthetic fuels, where companies are trying to show that they can end up with a positive carbon cycle instead of a carbon neutral cycle, that the dirtiness that you project to the world when you burn the fuel is lower than the capture that you do on growing the fuel or generating the fuel. So it's all about this end-to-end sort of ecosystem that we have to understand. Just like hydrogen, you have dirty hydrogen, you have clean hydrogen, and it's not just about burning or converting the fuel into mechanical shaft power to electricity. You really have to think end-to-end. So the whole concept of decarbonization, I think, is really important. I do see a little bit of interesting game between people who are pure battery electric and people who are fuel cells fighting each other, and I would sort of just say, hey, I mean, whatever is decarbonized is good. Everybody should go and compare themselves to the alternative, which is flying today, and anyone who's working trying to fix it is doing good work. So the fuel cell people and the pure battery electric people should really be best friends, because they have exactly the same objectives. And putting all your buckets, or all your investments in one bucket of technology and hoping it'll work fast enough for you, I think is silly, right? I mean, there are places where batteries are amazing, especially you have short-term, sort of short-range systems, and fuel cells just are unnecessary. And places, if you want to fly 3,000 miles, you're going to do it with a fuel cell. You're not going to do it with battery or some other clean technology. So one category, I think, for me is decarbonization. The second one is autonomization, especially how to make it safe. I think we want systems, both on the road and in our homes and in the air, that will protect us and protect themselves. I've always used the analogy of a horse versus a car. So if you ride a horse and you ride the horse towards a fence, the horse will stop by itself. And most cars, even self-driving cars, if they, the driver can force them to do something by just pushing harder on the accelerator, and the car will hit the wall or hit the fence. So we want our robots and systems to be more like horses and less like cars, or less like they sort of have to provide positive protection for us. And the whole concept of safe autonomy, I think, is very, very important. And we touched just briefly on mixed autonomy, which I think is an issue. So what is safe autonomy and deterministic safe autonomy and certifiable deterministic safe autonomy, I think is really, really important. And it starts with sensors and the kind of scenarios you have to operate, and can you see the world, and can you react correctly, all the algorithms, the software, can you react in a collaborative fashion, and its communication protocols, can you react in a non-collaborative fashion if it's something that isn't talking to you? A bird is not going to have ADS-B. There's no transponders for birds. They still have to share the airspace. So that's the second theme I think that's really important. And the third one is obviously VTOL. I think, in a way, the people have this umbrella of VTOL as one thing, but the reality is that you have VTOL that's mostly vertical, like a helicopter, more like a helicopter. And you have VTOL that's more of a runway independent, that it's just enough not to have a lot of ground infrastructure to get in and out, but you don't really want to spend a lot of time in this VTOL mode. And that diversity of system, I think, is really important. And talking about the specificity of which VTOL design and how it matches to the specific concept of operations, I think is really important. And I'd love to, maybe sort of, Srini, you have a lot of work that you've done in that domain. But I can see a lot of configurations that are considered VTOL, but they'll never fly in an urban city. Right? They're just not reasonable. And I see a lot of other VTOL configurations that will never fly 100 or 200 miles. They just don't have the legs. And that's okay, because the market is segmented. So 3 categories, as I said: decarbonization, safe autonomy, and VTOL.
That is a wonderful transition. Decarbonization, safe autonomy, and then that last one, VTOL, to hand it over to Srini.
Great. I think so. Gur covered a lot of the technologies, so I don't want to repeat any of those. Maybe I'll focus more on what does it enable for Aviation 3.0, right? And I look at it from the perspective of the consumer here and the people. So we've seen 2 large movements, I would say. One is less car ownership among people, the Gen X and sort of Gen Z. Fewer cars owned, more use of shared rides. And then this other concept, I mean, we just went through COVID, and a lot of these smaller routes started getting cut out. Like as airlines started, losing operating routes, they sort of gave up many routes. There's some consolidation going on. So the trend over the last 4 decades, as I understand, is that smaller routes they're not profitable enough to serve. And so you have airlines taking on longer routes with larger aircraft. And so regional mobility has pretty much become something dominated by cars and, surface transport. So my hope and what I really would love to see from all these electric aviation or whatever it is, you take an alternate form of fuel, is the cost per passenger mile going to go low enough to where people start using aviation for these shorter routes? And when I say short to mid routes, I'm talking 400 to sort of 500 to 1,000 miles. We still don't have aircraft that can operate profitably at that sort of range, but the hope is in the next 3 to 5 years, fixed wing with alternate forms of energy. Can they enable that sort of aviation paradigm? And I would really love to see, I mean, the idea of high-speed trains is very difficult in this country. I don't think there is enough public support for that to happen. But that is something that we need, is as fewer people own cars, fewer people are going to rent cars. Is there some other mode of transportation that can help them in these regional routes? Like, how do you go from here to Reno on a more consistent basis? It shouldn't cost $300 to go and come back. So if you have these small 10 to 15 size aircraft, which can be operated cheaper, at a cost efficient enough sort of pricing, that should be very helpful to people. I think that I would say the biggest trend that I see in the next few years happening. And along with this idea of multimodal, like if I don't own a car, the first and last mile become even more important. And that's where the whole shared ride concept comes in, right? I really love scooters, and I love the concept of having something to go to your nearest hub and taking a different mode of transport. So as more and more of these things get interlinked, I think that really benefits the next 5 to 10 years. Maybe the last trend I would love to, I know it doesn't tie directly into Aviation 3.0, is we are seeing these pedestrian-friendly cities. And pedestrian-friendly cities by inherently mean that people are not going to have places to store their car. They would want to live closer to airports or live closer to this sort of transit centers. And so aviation becomes even more important. And so the idea that airlines take away the smaller routes and people go back to driving hundreds of miles, it doesn't sort of gel well. So that's how I would put it. I think technologies wise, Gur, you covered it all. Whatever the form of energy is, it needs to be net neutral, right? You don't want to contribute in production what you really save in consumption. So it has to sort of balance it itself out.
I'm also a fan of the scooters, but I need the helmet. That needs to be a part of it.
Yeah.
Thanks, Srini. Peter.
Yeah, so I think that it's, for me, it is really about things that support resiliency writ large. So what we want to do is we want to take down the barriers that allow this technology to get into the air and to start to scale, because lots of good things happen once we do that. But in order to do that, there are certain things around resiliency. Gur mentioned certifiable autonomy. I find resilient navigation to be a very interesting space. The cybersecurity around data exchange in a wide geospatial system. The technologies that give these air vehicles more of an all-weather capability. And so how are they going to navigate? How are they going to tolerate cold weather? How are they going to reject gusts and deal with high wind situations? Those are all interesting areas for us that are taking down these types of barriers that are allowing these systems to start to actually get used in a practical sense. I also think that, a very interesting area is the notion that this type of aerial mobility is going to enable operations that depart from and arrive at many, many different locations on the ground. And that is something that the existing airspace system is not really set up to accommodate elegantly. And in fact, in the existing airspace system, it's very human-centric in terms of the operation, right? We have visual flight rules and we have instrument flight rules, but we don't yet have an additional set of flight rules that support these types of automated systems in a way that is really integrated into the rest of the airspace system. But there's some very interesting work that's going on that is standing on the shoulders of IFR, of instrument flight rules, that is taking some of the same theory, the same proven safety cases, and literally some, the same math around those geometries and around the those airspace and trajectories that are being defined, and scaling it down to something that would fit the needs of shorter hop trips, that would fit the needs of cargo drones, for instance, and also something that would accommodate the much greater number of points of departure and arrival that we all aspire to do. Because if we can have, if we can create a system architecture for the airspace system that enables operations that support autonomy, that are provably safe, and yet that accommodate arrivals and departures from many arbitrary points on the ground, then we've taken down a big barrier, and we've really opened up a window for private sector innovators and for entrepreneurs to start to leverage this system as a platform and apply it in a bunch of different interesting areas that we really haven't spent a lot of time thinking about, but we're going to see a lot of creativity if we set the table in the right way.
So Srini, a date. When do you think we'll be able to take a ride in a flying car?
I would say roughly 6 months after certification.
Well, that's the question. When's the certification, and then when we'll be able to take a ride?
No, I think it's in the past I've sort of talked about the timelines, but if anything that we have seen from this integration of airspace, a lot of things with FAA have a lot of things have transpired in between. I would really, that's all I would say is type certification. A lot of OEMs are going through it. Whenever it is safe and when FAA feels all those sort of requirements have been met, within 6 months from that, I really wouldn't want to predict when FAA would be able to do it.
Yes or no? Will it be autonomous?
No.
Okay. Sorry, Howard, I interrupted you.
Sorry, can I just jump in with a follow-up on that question? And it doesn't have to be Srini that answers it because I know he's sensitive to SEC issues. But on the certification, I mean, there are a lot of companies trying, electric aviation companies trying to get certification. Can anybody say something in general about how that certification process is happening? I mean, for example, I know that the FAA has shown themselves to be much more flexible and lenient. Lenient is wrong word, but flexible with respect to this new area of certification. And Gur, maybe you're the one that can talk to us in a more general terms about the speed at which this is progressing.
Sure, I'm happy to. Very quickly, certification comes in two large swath forms, right? You can think about general certification like Part 23 or Part 25, small aircraft, larger aircraft, or Part 27, 29, small helicopters, larger helicopters. Well, once you certify the aircraft, you can do whatever you want with it. And then there's more mission-specific certification, which is really what's going on in the small drone space and even some of the flying taxi space. There's a new spec called 2117 A or B, and you get to choose which variations you want to play. And that's that the FAA basically put together a lot of the different rules from 23, from 27, depending on what form factor and mission you're trying to perform, what aircraft and what mission the aircraft is trying to do. Now, if you like to be certified to fly over the forest and there's nobody there, so the shelter factor, there's nobody around, so the consequence of an incident is none, then it's very easy to get certified. And if you're trying to fly in downtown San Francisco at low velocities in a highly congested airspace, then the certification levels are going to be very high. So the first question you want to ask is, where is that mission taking place? And the more complex the mission is, the harder it is to certify, because you have to demonstrate a higher level of design assurance level, DAL. For example, in Europe, to fly in urban cores, the EASA on the record went and said that they want to 10 to the power of -9 reliability. So that's the highest level of mission assurance, same as a Part 25 jet. Think about your large Boeing, large Airbus. Where in the US, a lot of the players, as far as I know, Srini, you may know better, are going after Part 23 certification, which is a couple of nines less in reliability. Now, that means you're just going to be able to do fewer missions or more constrained missions. Maybe you have to spend more of your time over water. The overflight of the population will be more limiting in terms of the mission trajectories you have to pick. So that's basically where it is, right? I mean, you have to sort of design the concept of operation, and then you have to make the safety case, and have to demonstrate that your system is able to assure mission assurance at these safety levels.
I think I would agree with that. See, there are a number of different configurations, unlike just fixed wing, where you would have added a certain Part 23 and you would just certify across that. eVTOL is a new generation of aircraft. You have both vertical lift, you have forward cruise. You also have the question of redundancy. And so as Gur pointed out, EASA created a whole different category, and they kind of said, if you are commercial revenue generating and between 1 to 5 passengers versus 5 to 9 passengers, they created all these tiers with different levels of DAL certification. So you could be a single person eVTOL just doing sort of leisure operations of light aircraft certification, and you could do that at 10 to the power of -6. But if you wanted to be carrying 5 passengers and you want to be doing commercial revenue operations, and it have to be 10 to the power of -9. The FAA hasn't done the same kind of separate classification. What they're trying to do is use some of those existing rules, but add new basis for anything that differs from that. So they're going after the deviations. And so this is one of those things that has been going on for about 4 or 5 years. I think they will have to at some point publish that these are the acceptable means of compliance. And once OEMs receive that, then they have to show that they're complying with that. And so that is the process that many OEMs are going through. And so that's why it's not a clear date, because they are really working with different OEMs to almost be very custom to that. But if anything, they've shown that they're flexible. I think what they learned from the whole drone sort of, I don't want to call it a debacle, but we've lost the lead because we have been very, very restrictive in the airspace. And as Peter pointed out, the drone ID took many years. Integration of drones into the airspace took many years. And we had these rules that impeded the operations of many companies. And so now with eVTOL, we've sort of taken, trying to take a leadership role. We've seen that with Agility Prime. We're seeing that with NASA. I think FAA is far more incented now to work with OEMs to make sure that lead exists.
Thank you, Srini and Gur. Maybe Richard Barnett asked a question that we will end on, and I will direct this towards Peter. If personal air transportation takes off, how will we deal with congestion in the skies?
Okay, so it depends upon what chapter of personal aviation we're in, and what technology we have in the airspace system. I mean, if we fast forward far to the future and we have really resilient end-to-end autonomy for the airspace system, then we can massively reduce the spacing between aircraft up there in the air, and we can accommodate a huge amount of traffic. Think about the amount of traffic that we accommodate in the very small volume of space that is a modern highway, and the number of vehicles that we fit through that, and then compare that to the volume of space that is 1,000, 2,000 feet above us and over that entire city. The question, though, is, it's a long time to get to that level of automation and that, and maintaining that type of safety. So along the way, we are going to have a series of steps where someone will create a breakthrough in certifying a vehicle or in defining a new set of mission operations, and they will run with that and they will scale it up, and then we will encounter bottlenecks in some other part of the system that restricts the capacity of that overall service. And then on the back of that, we will have to address that bottleneck, whether it is RF communications and data exchange that becomes the bottleneck. I mean, that's certainly a bottleneck right now in the airspace system, because the way that we communicate between aircraft and the ground and infrastructure is voice over VHF. And so, anyone who's flown an aircraft or listened in to pilots talking to air traffic control, you realize it's one big party line and everyone is verbally repeating the instructions that were given to them to confirm receipt. So we're going to have to successively take down these bottlenecks and increase both the capability in the airspace from an automation standpoint, as well as increase the capability in the airspace from a aircraft density standpoint. What are the safe spacing and how do we route those aircraft through? And I think that we're working to get ahead of that at a system level just to enable these first flights. But it's going to continually be give and take, I think, between people that are developing air vehicles and applications, and then the capacity that is built into the airspace system itself.
Well, Peter, Gur, Srini, that was super insightful. I learn every time I chat with you, and it was nice meeting you, Gur. Howard, Nick, Andrew, thank you so much for having us. We hope the audience enjoyed learning a bit more about Aviation 3.0, and we will leave you all to your break, which I think is next. Thanks.
That's great. Thank you so much, Tess, for leading us through this very complicated but really fascinating subject masterfully. I think what struck me about this discussion was how well it integrated with the larger discussion of the day, because after all, aviation is part of the bigger mobility revolution that's happening, and you did a great job of demonstrating that.